Today is the last day of AICTE-ISTE sponsored 6-day program, and welcome to the first session by eminent speaker with us today, Dr. Neeraj Sharma sir. Sir will give you throw light on this bio-inspired techniques and their applications in the field of biomedical engineering. I request Vaishnavi ma'am to introduce sir to all the participants.
Good morning, sir.
Good morning.
I'm very happy to introduce you today, sir. Dr. Neeraj Sharma, sir, is working as professor in the School of Biomedical Engineering, IIT Varanasi. Sir has obtained his PhD in the field of biomedical engineering instrumentation from IIT Varanasi. Sir has completed his MTech from NIT Kurukshetra in the field of instrumentation. Sir has completed his BTech in electrical engineering from NIT Kurukshetra. Sir has more than 70 research papers in reputed journals and conferences. Sir has completed 2 research projects and and 2 collaboration projects with Parvartan Technologies Private Limited. Sir also completed 2 consultancy projects in the year 2008 and 2011. Sir's area of specializations are biomedical instrumentation, image processing, artificial intelligence, and bioinstrumentation. I welcome you today, sir.
Thank you. Thank you for the introduction. So, shall I start with the presentation?
Yes, sir.
Okay. A very good morning to all the participants. Today, I am going to present before you the optimization techniques and their application in the field of the biomedical engineering. So, basically, to start with the optimization, so the first is, what is optimization? So optimization is mainly application of techniques known to you for maximizing or minimizing certain goal for a given applications. And nowadays, let me tell you very clearly that optimization has become clearly a part of tool or clearly you can say a tool of hybridization. This is clearly a tool of hybridization with AI techniques. In some cases, you can apply it as a standalone technique, and in some cases, you can couple it or hybridize it with existing ANN, artificial neural networks, or fuzzy systems. And optimization techniques derive their base from almost all the bio-inspired phenomena, just as your particle swim optimization is one, and classical is your genetic algorithm. Okay, and this also derived from phenomena of the physics like simulated annealing. We have also applied simulated annealing for lot many applications. We have used genetic algorithm also, particle swim optimization also, ant colony optimization. So many examples are there from bio-inspired origins or physics inspired origins, which finds application in the optimization. And mainly in the classical optimization, we go with the d by dt techniques, d by dt or d square by dt square, double derivative or single derivative. And the concept is that wherever the change is there at the point of the maxima or minima, there will be the change in the slope point. So there the derivative functions work very well. And you also find that these optimization techniques have been used directly in the training algorithms also, like in backpropagation algorithm, backpropagation based learning algorithm also, you will find that it's your derivative based. It's basically a derivative based weight and bias optimizations or bias finding. Okay, by back iterating and then optimizing, we search with this. So all these are the derivative based. So the derivative based is having one main requirement, that the function which you want to optimize must be continuous in origin, must be continuous in shape, or you can say that, or with respect to parameters, with respect to your input parameters, the function must be continuous. Only then your derivative based approaches work very well. And this has got some limitations also, because nowadays when we are working in the era of multi-dimensional and multi-objective functions, I will of course come to the what are the objective functions and how they are laid down. So laying down the proper objective function and deciding the dimensions or dependency on the parameters, on which parameters or we want to optimize, is an important task. And then deriving the mathematical model or formulation for that very objective function is also very important at the same time. If you have been able to correctly specify your objective function, only then your optimization techniques can be clearly applied. So now let me come back to the main point, that for the derivative based optimization techniques which we apply in backpropagation learning algorithm, that is the that works on the optimization of the error function, minimization of the error function. Okay, so there the requirement is that your function must be continuous. But there are, when we are working with the multi-dimensional, multi-objective function, so we cannot guarantee that our the objective function is a continuous function. So there, the role of these very bio-inspired optimization techniques comes. They are very well capable of searching the search space, even if it is having not only single discontinuity, but with multiple discontinuities also, it can work very well, and in very good for multi-dimensional. So I will just tell you the techniques also how to deal with the multi-dimensional systems with multiple objectives, and you can even meet the goals which are in, you can see that in opposite directions. For example, if you want to optimize the, you can say that if we are driving a car, there may be two goals. One goal is to optimize the time. That is, I should go with the max speed or the speed which is going to save my time. At the same time, the other contradicting goal or the other goal could be the optimization of my fuel efficiency also. So in case if I want to meet these two objectives, then definitely I will have to lay down some points where I am optimizing my speed also, and the same time I am able to optimize my fuel efficiency also. So for that, normally in your vehicle, you find that some green band is there, that is in the band of the 40 to 55 or 60 speed of a kilometer per hour. So these are some test trial conditions on which the company claims that if you drive at this speed, your fuel efficiency will be maximum. At the same time, you can also optimize the timing also. So in this way, you are to deal with the multi objectives also. So the objective of the optimization problem is to seek values of parameter that maximizes or minimizes the defined objective function. So defining objective function is also an important task, subject to certain constraints. You can also define what are the constraints. That means within, you can also specify the boundaries in which you want to operate it. For example, you might be giving it a task that I'm reached from point A to point B within this very specified time. Okay, so accordingly you can deal. This is the one constraint you can. Then you can also mention what will be the fuel efficiency required, and so on. you can lay down the these are simply the two objectives. You can, in this term, you can lay down the multiple objective also. So optimization technique finds application in lot many fields such as engineering designs, activities, medicines. Particularly, you will find that in the radiotherapy treatment, which I am going to include as an example, that it is required that how to optimize the radiation dose, and from what angle it has to be given, to let the dose to the cancerous tissue is given 100%, and to the nearby organs, which are crucial organs, which are to be prevented, is minimized to them. So they can be applied to industry, they can be applied to decision making, and so on. Okay, so this is the reference which I have used here. Okay, so Abbott and She are the classical, you can say that are the authors who have proposed the algorithm for particle swarm optimization, one very classical and popular algorithm for the solving the optimization problems. So any maximization problem can be converted into minimization also, if I can also reverse the goal by taking the inverse of the objective function. So this way you can do the inverse. The optimization technique can be used to solve minimization problem defined in this way. I'll just taken as an example. And of course, you people have been doing this dealing with the optimization algorithms for the last week during this. So I will quickly go through these basic principles. So there could be existing local optimal solution. Just example. And there could be existing only one global optimal solution also. Okay, in the search space. So search space is basically nothing. If it is a one parameter dependent objective function, we call it as a one dimension. Let it be x1. If it is two parameter dependent, we call it as a two dimensional search space. If it is three parameter dependent, we call it as a three parameter dependent. But if it is n, it could be n parameter dependent objective function also. So it could be in this way, multiple dimension. It could be 10 parameter, 20 parameters, or 100 parameters, whatever your objective is to optimize or find out some solutions. So in order to this could be multiple dimension search space. So this decides, xn decides the dimension of the search space. Corresponding to every input parameter which you want to optimize, there will be one dimension in the search space. So now this plotting, this I have taken a random plot. This is one local minima. These are also the locations of the local minima. These are the locations of local minima, and there exists only this one and one global minima. So whenever we are trying to find a solution, our objective is to reach to the global minima point. And particularly, there are some such standard test problems, just like restriction function, spherical function, which I will just show you these also, which we can use for the testing of the optimization algorithm. So they are standard test function, and of course one classical one is the traveling salesman problem. Traveling, you might if you have been working in this area, you might have attempted to solve this traveling salesman problem. You have to optimize the distance travel. At the same time, you have to cover all the cities. Okay. So apart from this, we are having standard test function like restriction functions is there, spherical function is there, and then AICTE forest function is there, which are very complicated, and you increase the dimension, and you can really test how your algorithm is. You can really test how your algo is working in that case. You can definitely test them on the standard test function. That will give you an insight about the functions you have been working with. So in case if you want to add the constraints, so these will be the constraints or the boundaries. You can always lay down the boundary for this one. For example, here, this is boundary, this is the boundary, and in between boundaries, we have to provide the solution, find out the solution. So this may be a local minima, this may be a global. This is going to be a global minima, and in this way. Of course, if we move out of this very constraint, then this will be your global minima condition. The process of finding the global optimal solution is called as the optimization. Basically, we primarily wants to go to the position of the global minima. Okay, so now in every algorithm, every optimization algorithm have the following hierarchical steps. The first step is you have to choose the design variables. That means your inputs are to be decided. Inputs are to be decided, and this will decide your search space also. This is the first step. Second is formulate the constraint. That is the boundaries. If you want to lay down that this will be your the minimum and maximum boundaries condition, or this will be the range of the different parameters. You can also define the range of the parameter. Then formulate the objective function. So this is the main primary important task that is totally dependent upon the user. So if you can do it by knowing what are your objectives. It could be single objective function. Also, it could be multiple objective also. It could be multiple objective function also. And in multiple objective, different hyperplanes and planes and surfaces will be there. And after that, you have to decide. So you can see that the problem will be more complex. Accordingly, the complexity will increase. Complexity is dependent upon two things. That is number of inputs or your dimension of the search space, then the number of objectives. Then you are required, supposed to write down the mathematical model. You will have to build down the first of all mathematical function corresponding to your objective function. Function for objective function. So these are the two main tasks. Now, once you have done these three steps, the important steps, mainly user defined, then you are going to do the search space, choose an optimization. Now the next step becomes you can choose an optimization technique. So there is a battery of the whole battery of the optimization techniques which you can apply for your application. So you can select any one optimization technique. It could be from classical optimization techniques, or it could be from bio-inspired optimization technique. And even you can apply AI techniques. Artificial intelligence can also serve as a tool for optimization. AI is also having very good capability to serve as optimization. Of course, optimization could be part of the AI, but AI is also capable of solving your optimization problem. Okay, then finally, it provides a solution after going through iteration and search. So next step is to application of optimization algorithm to solve biomedical engineering problems. So biomedical problems are complex in nature, having multiple input parameters and objectives. So we will discuss here 2-3 problems. Today I am going to discuss before you the 2-3 problems. They are namely the optimization in the radiotherapy treatment, then application of optimization in image processing. This may be in this we are going to include your segmentation algorithm. We can include your enhancement or algorithms, image enhancement algorithm. Then third problem, if time permit, or I will like to show you how we can mathematically model the different different biological systems, and these models can be used for the clinical studies, how the system is responding to an aging system. Okay, so in recent year, so bias-paired optimization algorithms, they are overpowering rest of the techniques. Okay. Now, today I am objectively going to take, first of all, these two examples, the particle swarm optimization and the genetic algorithm and their applications. So the objective is to present the two most inspired. Why I have selected these two algorithms? The main objective my presenting before you the two algorithm is that one is based on the Darwin concept theory of the survival of the fittest. That is, if the population is there, then out of this, the fittest is going to survive. So this is particularly based on the concept of competition. Competition among the individuals, competition among individuals. So according to Darwin concept, there are two types of struggles: interspecies struggle, and intra-struggle for survival. Okay, inter means among the different species, how the struggle is going to be there, and the fittest species will survive. Then after that, intra-struggle means that is within the group, the next level of struggle is there for the fitness and survival. Okay, so this is how this concept of the genetic algorithm is based. On the other hand, in contrast to this, so the PSO is in contrast to this. PSO is in contrast to this. This is based not based on the competition. This is based on the cooperations among the individuals. Cooperations among individuals. That is, for their group survival, they share the information and they work with the cooperation with each other. Okay, that is, every individual is working for the betterment, and whatever the best information is there within that group, that is utilized. For example, if there are two ways of solving a problem. I can give it totally to the whole individually to the group members and ask them to solve, and whatever the best solution is there, I can accept it. Second method is that I can make the group within the group of the individuals and ask them to solve by using the cooperation. So every chance is there that the group, when given the group task or team task, the efficiency or performance is better. And this we have also tested in the algorithms and proved also that whenever the PSO performance is definitely, simply because it is based on the cooperation, is much better in solving complicated test problems. We are having the proven results that by the cooperation, the results achieved are better. So we have tested this algorithm, this type of algorithm, on the, you can say, the different test functions, and practically shown that if both algorithms are run for 10 times, and out of this 10 times, it probability to find the solution is 8 to 9 times, whereas the GA will be able to find out the solution to 4 to 5 times. And with the increase in the problem, the probability of or the performance improves in PSO algorithm. So this is how you can use these algorithms or understand the basic underlying concept of these algorithms. So for same, we have selected the following key applications: optimal segmentation of the images. First, I will be taking this one, then mathematical modeling. So sorry, you can change the order, no problem. So both PSO and G are bio-inspired algorithm. PSO is based on the concept of the cooperation between the individuals, and while G is based on the concept of the survival of the fittest, i.e., that is the competition between the individuals. Okay. So principles of genetic algorithms. So first of all of you are familiar with the genetic algorithm. We'll quickly move through these algorithms. So, and okay, so I will emphasize on the main key terms. I will emphasize on the main key terms which we are supposed to take care while working with optimization algorithm. So before proceeding, I will give you this two. So genetic algorithm is parallel global search. Of course, this all these algorithms, which are population-based algorithms, like genetic algorithm and particle swarm optimization, can be parallelized. So this is one of the major advantage. Parallelization is a major advantage. You can run them in parallel configuration. Nowadays, you know that the parallel processing algorithms are gaining popularity because of time saving. So you can very well work with the parallel algorithms, or these algorithms are very easily parallelizable. Either you can use the kernel model or any model for the parallelizations. Okay. Search-based technique based on the ideas of genetic algorithm and utilize the concept of the Darwin theory. That is the survival of the fittest. Now, what are the two goals of any optimization algorithms? Any answer to this? What are the two main objectives of the any optimization algorithm? Any answer to this question? What are the main objectives of any optimization algorithm? Anyone will like to answer this question? Yeah.
Can you repeat the question once?
My question is that what are the main objective of any optimization algorithm? How it moves?
Right. To get the feasible solution or near optimal solution at least.
Okay. Any other point? Any one other will like to attempt?
And
okay.
Either to get the minimization in terms of if I want to get the more profit, I have to maximize, and if I want to reduce the number of human hours, I can minimize that particular optimization problem.
Definitely, very good answer. But one more thing I was expecting is, let me ask it in some other way. That what is the probability that your algorithm will reach to the global minima or maxima solution?
I think it depends upon the number of variables that we are taking. I mean, the number of outputs that the system is going to produce. Is it a single objective or multi-objective? Okay. Or it depends upon the unimodal or multimodal, how many number of local minimas that the particular system is having.
Definitely. So what is the probability that it will not get trapped in local minima? Okay, let me answer now. Let me answer now what I wanted to tell you. So whenever you are working with the optimization algorithm, there are the two tasks which is going to accomplish. The first task is exploration. And next task is your exploitation. Exploration and exploitation of search space for probable solutions. So what is exploration? Exploration is basically when this is the task, or we want our algorithm to work in two stages. So it will always be better for you to design algorithm and tune its parameters. It will always be beneficial to design algorithm for optimization or tune it in such a way that at first stage the task of exploration is done. Then at second stage exploitation is done. What is exploration and what is exploitation? Suppose there exist different minimas or different conditions of a minima in the search space. Suppose this is existing at this point, this point, this point, or this point. So I will like my algorithm to do the exploration. That means it must clearly explore what are the probable solution. So in the exploration, my movements may be in big steps so that I'm able to traverse all of my search space. Suppose there could be n number of individuals or n populations which I have initialized. Genetic algorithm is basically a population-based algorithm, and my first step is to begin with the initialization of the population, and population size or the individuals within a population and population of the group will be decided by the is decided or affected dependent upon the complexity of the problem. How complex is your problem? How many individuals are there? How many dimensions are there to be search space? And what is the status of your objective function? So in this form, there could be existing different solutions in the search space. So first of all, we go with the exploration. And once we have found out these are the probable solutions, then we go with the exploitation. Exploitation means, or you can, in simple language, you can understand this as coarse tuning. So whenever you are doing some, you can say that frequency selective operations in your communication engineering. So first of all, you do the coarse tuning, then you can go for the fine tuning. Coarse tuning means first of all picking up the particular band, then fine tuning means particularly going in the fine details and adjusting as per that one. So exploration is similar to that. The coarse finding one. Then earlier also in your radios you might have seen that there used to exist two knobs. One was for the coarse tuning, another was for the fine tuning. So that is the same thing in this algorithm. First of all, the exploration process will be done, executed. That is, in this process, we can allow the algorithm or the individuals to go with the bigger step to find out where are the possible solutions. Once we have find it out that in the d-dimensional or multi-dimensional search space, these are the location of the probable solutions, then you can go for the exploitation. Then you can go for the fine tune. Let me tell you with this diagram itself how it is done. That is, suppose this is the solution. You have find it out that these are the probable basins where the solutions are existing. Just forget about this constraint. Let us suppose that these are the 4 minimum solutions. Then every individual will be allowed to do the fine tuning. It will be allowed to move finely, and initially the steps could be the bigger one to reach to this point. Once it is reached, then we can move in a slow step to find out the exactly the minimum condition. Suppose this individual particle, let us say this be x1, this has been able to find out, or let it be p1, sorry, x I have already used. Let it have find out the minima m1. Then the particle at this place before coming it might have been coming in bigger step to this point. Once it's reached to certain point that now yes this is the minimum location which is just fine, then it can go on reducing the steps. So finally with the reduced step it will move to very this one solution. Okay, so this be the minima m2. In this same way this particles can move in this way and then settle down to the final solution. So the steps, these steps can be treated as equivalent to exploration process. Exploration. And the final step when this algorithm is trying to settle down can be called as the phenomenon of exploitation. So two steps you can always break. In the first step, we can move with the bigger gains values. Then finally, we'll have to settle it down. Let me show you in how G and PSO we are going to deal with these two parameters. So if you in earlier talk, if anyone of the speaker has discussed about the G and PSO.
No, sir.
Okay, no problem. Then it will be fine that I can go with these in a little bit more details. Okay, how these algorithms are going to work, and these are going to. So exploration and exploitation. Every algorithm, whether it's a particle, this optimal, this your whether this is your bio-inspired algorithm or any other algorithm, main two objectives are there: coarse tuning, fine tuning, exploration and exploitation. So these two way you can explore. And third concept is to improve the which this is the goal which we are going to achieve with these two phenomena, that is to improve the diversity so that the algorithm doesn't settle down at the some local minima conditions. So the main feature of the GAR parallel global search method based on the mechanism of natural selection and natural genetics. There is no need for linear and differentiable search space. So this is the main advantage when we work with these type of algorithms, that we don't care about our search space, how it is, if there are some what type of traps are there, if it is differentiable, continuous or discontinuities are there, linearities are there, or non-linear space is there, or a non-linear function is there. So these algorithms are very well capable of handling all these non-linearities also. They can very well handle non-linearities and discontinuities. So this is the main two advantage when we are going to work with these algorithms in our application. So GA applies operators based on crossover. So how we are going to operate now GA? Basically, we realize the population of n individuals. Suppose let me take a basic example of, you can start minimum with a 30. Of course, you can go with, depending upon the complexity, you can go on with the more population. You can go with 300 also, or 1,500 also, and so on. You can move in the step of 30 and then hundreds. Okay, depending upon the complexity of the problem. So more the individuals, better will be your solutions. But of course, it will be at the cost of computational cost. The better solution will be at the cost of computation. So again, we make some trade-offs depending upon the complexity of the problem. That if it's a basic problem, we can go with the 30 individual, 50 individual, 100 individuals, 200, 300, 500, or even larger set of individuals. Now, because of the availability of the GPUs and multi-core processors very easily available, multi-core processor GPUs and even your supercomputers are easily accessible, we can go with the you can say that larger number of individuals that guarantees the best possible solutions to your problem. So crossover. So within this, once we have realized the population, then it will be evaluated for the fitness function. Then out of that, the fit candidates will be selected to produce the next generation. So this is by the crossover. Then to increase the diversity, or this we can we have to go with the mutation factor. We have to mute them. So you might have seen a movie on the mutants also. So sometimes you find that the mutants, it is expected sometimes that the mutant may be having some better characteristics to survive, or there could be also reverse also. Most of the time it is reverse, the mutant are not able to survive, but it is that movie, the concept was that the mutant may be having some better features to survival and give the better solutions. So mutation is the one factor which we use to improve the increase the diversity. So in this way we can go with the random flipping of the solution, and at the same time we want, what we can do from the exploration point of view, we can keep the mutation factor or the probability of the mutation more. For example, it could be, we can allow all the 80% individuals, 80% individual, we can allow 80% individual to go with the mutation in the starting phase, that is to improve the diversity or the exploration process. Then we can go on reducing this. For example, in the after next few iterations, we can reduce it to 70, then we can go to reducing 60, and finally we can reduce it to 20% mutation only. So that now this is the factor which we can tune for particularly, you can say, to improve the diversity or the control the phenomena from exploration to exploitation. We can control this phenomena for moving from exploration to exploitation. Okay. So, and thus is capable of generating wide range of population, that is the search space, and each generation which help GA to come out of the trap of the local minima. It required less knowledge of the system properties. So this is another advantage, that without going deep inside the your problem, what is actually this is and how the systems are working, you can directly implement this GA or PSO-like algorithm. So these are the steps in genetic algorithm. Encode the decision variable as chromosome. So it will simply depend upon the chromosome, will be nothing, but suppose this is your d-dimensional search space. Suppose my x1 is the vector and my individual let me represent it with p1. P1 is the vector corresponding to individual 1, P2 will corresponding to individual 2, up to so on. Suppose I initialize 30 population, it will be P30. So it will be, then I can 1, if it is suppose in d-dimensional search space, so it will be x1 1 first variable, x12 second variable, and so on up to x1d or n for the n-dimensional search space. Now I am representing it with d. So this is depending upon 1 by d. Similarly, this will be x2 1, x2 2, x2 d in this one. So this 30th will be then x30 comma 1 for first dimension, x30 comma 2, sorry, x30 comma 2 to x30 comma d for 30 particles. So this is how my 30 particles will be generated. So encode the decision variable as chromosome. So these decision variables can be very well encoded as binary number. This, if it is two state only, it could be coded as a integer number. It could be coded as a real number also. So any of the format you can encode them. So make population, initial population set of chromosome at first generation. Suppose I have taken now this as an example of 30 individuals. Evaluate objective function for present population. So all my objective function will be evaluated for all the 30 population. I will be varying from for all I from 1 to 30. Okay, objective function will be evaluated. Then out of this objective function, select the parents' chromosomes with higher fitness values. So I will arrange the parents or the individuals with respect to their order. For example, it could be suppose PK, whatever, P3, P4, whatever my best 15 I can decide. Out of this 50% population or 60% population, I am going to select which is having the best in the, I can arrange them in the increasing order of the fitness value of the objective function. This is the value of the objective function. So select the parent chromosome with higher fitness value as computed in the previous step, okay, and specified by the user. Then generate new population from the parents selected in the step 4. So these now parents, I can divide them into two groups. Okay, so parent selection, there are 2-3 techniques I will just discuss after within this. Tournament selection is there. Okay, tournament, just like in the tournament, we can go for this, or a roulette wheel selection methods could be applied. The individual with the more fitness can be given more space on the roulette wheel selection, tournament selection. Okay, so the different techniques are there through which I can, yes, select. So out of this, I can suppose I have selected 16 parents, then I can make them, divide them into the 8 and 8 group, and then again generate a new population of suppose population of 30 individuals, 30 new offspring. So now this 30 new offspring will participate in the next generation. Okay, then the next step to improve after the crossover, the next step to improve the diversity will be the mutation process. The mutation will be then flipping off out of this very cross products generated. They will be flipping them. Mutation means flipping them in the subspace. So crossover and mutation. Parents selected in this step will go through the crossover mutation. Okay, and after crossover and mutation, so again go to this step. This will be continued unless and until we are going to achieve the best chromosome with the fitness value, and that is the solution for your given problem. So suppose at the end of the generation, suppose it may take 100 or 105 generation, 105 generation, superscript for the generation. Suppose particle selected or the individual selected is 21st, then this 21st individual will be the solution to your given problem. That this is the value which is satisfying your objective function. Okay, so one more thing I like to add at this point. From the crossover and mutation can be goes on. We can go on decreasing the mutation factor, and we can regarding the crossover technique, I wanted to tell you, just like we can have 2-point crossover, 3-point crossover. So on this side, just like we are having the most significant bit, on this side we are having the least significant bits. So I can prepare a strategy to when my most significant bits are going to be taking in participation, we can make it adaptive also. when most significant bits are going to take in the crossover function, lot many crossover functions are available. You can simply end the functions, you can simply OR the function, exclusive or any other strategies or function you can apply from your side also. So if most significant bits, 3-point crossover is there, if most significant bits are participating, then the new offspring generated will be having much different characteristic. If least significant bits are participating, then slight variations will be there among the individuals. As you might have seen that in the families also, you find that the characteristics of the offsprings are matching that of the two parents. Either the child is going to acquire the characteristics of mother or that of the father. So it depends upon how the crossover has been carried out and which one is the dominating gene. You could lot many concepts are there. You can just play around with the crossover techniques. You can select the elitism also, that this is the elitism means dominating genes, that these are the dominating genes and they will be just carried. And in the similar way, you might have seen that there are some hereditary diseases which move from one generation to another generation, just like your color blindness is one, hemophilia is one. So that means there are some genes or which are propagating. So in that way, this is just the reverse. In that way, we want some strong genes to dominate. For example, the height of the offspring in families is normally from the you can say that or normally the children normally gain height as per the tallest of the two parents. If father is tallest, then of course the height of the offspring will be on the taller side. Okay, if mother is taller, then it will be on the mother side. So this is called as the dominating gene concept. So most significant bit, least significant bit. Accordingly, you can design a program which is going to behave in this way, and you can select it. And mutation means flipping on after the crossover has been done. You can flip some of the genes of this very offspring. Again, they can be flipped on the either on the most significant side or least significant side or in between side. And this can be gradually shifted from most significant bit to least significant bit, or you can also add a probability terms. If a random number is more than 0.5, the probability is more than 0.5, or if 0.5 is there, that means the population selected. Suppose 30 individuals are there in the new generation. That means out of this, 15 individuals will go through the mutation. And this way you can go on decreasing this factor. At last you can keep it 0.2. That means only 20% individuals will then be allowed to go through this. That means now your solution is toward the convergence. So or now the algorithm is going to behave more in exploitation mode. Okay. Then this is from the PSO. Now next thing I'm going to take about the PSO. PSO was initially inspired from the bees dance. So they use a different group of bees goes to search for the nectar in different directions. Okay, and on returning, they used to dance in a particular fashion and a particular manner. So that used to inform about the nectar or the honey which they are going to mine, the quantity of honey, and at the distance. Quantity of honey and the distance. So the two things are there in this. So if the honey quantity is more and distance, if the both two parameters were needed to be optimized. So accordingly, they used to decide in which direction now today they are going to mine the honey. Okay, so this is the angle, direction, and the radius, which gives the information about the nectar and the distance. So this is the particle swarm optimization form. Another example of this is the movement of the bird flocks when the birds move in larger population. So what is PSO? We'll quickly go so that some time is there to discuss with the applications. So PSO is a population-based stochastic search method inspired by the social behavior of bird flocking and fishing school and was originally proposed by Kennedy and Abbott in 1995. In PSO, a number of particles in the form of swarm fly through the search space to search optimal or near optimal solution. Each particle coordinates represents a possible solution to optimization problem. The movement of the particle is influenced by its own best position, whatever it has explored, then position of the best particle in the total swarm. So when we are going to do this, implement this algorithm, so iteratively we'll be updating the particle on best position and the group of the particle best position, the best individuals or the best position will be marked as the global best position. So we are going to term this as L best, and G best. Okay, and so cooperation between individuals, the group is able to achieve its goal efficiently and effectively. Okay, so these are the references which you can see. Then this is the mathematical model for particle swarm optimization. Suppose this the concept I have already established. Xi is the individual in d-dimensional surface, xi1, xi2, xid, ith particle in d-dimensional surface. Pi best is the particle on best position. Then G best is the global best position searched by the swarm. This is the individual best position part searched by the swarm. That is, at any stage, if particle is at some of its best position, it will record it. Then whole of the group is going to record by the comparison which is the best position among that very group. That is called as the G best position of the swarm itself. And at each iteration, the velocity and position coordinate of the particles are updated according to this very equation. So this is your velocity at the t+1 iteration. This is the weight vector. That is how we are going to inertia weight corresponding to the initial move. This Vt is the initial velocity. Velocity one step back. This is computed at this step back. C1 is the factor cognitive constant. So cognitive constant, that means the confidence of the particle in its own best position. C1 is the cognitive constant. C2 is the social coefficient, that is the confidence of the group for the corresponding to the global best position. Now, in this particle swarm optimization algorithm, C1 and C2 plays a very important role in the controlling the exploration and exploitation. How? If my C1 I can have the values of the C1 from you can say that 0 to 2, and G also I can have from 0 to 2. Okay, 0 to 2. Just as an example, if initially what I can do, I can rely more on the individual position. That means this can be kept large. Suppose I am having this value to be 2 and this value to be 0.1. So if this value is more, this value is on the lesser side, then exploration will be there. Okay, that means every individual is allowed to explore the search space in his own way, and it will be given full weight to its own best position. Then after that, when the iteration process, I will keep on decreasing this. At the end, I may go with the decreased value of this one, 0.1. Okay, and this may be increased to 2 itself. So in this way, what is done now, I will say that now stop doing the individual search at the later stages. Stop doing the individual search. Now rely what you have collectively collected. Okay, that means now I want my algorithm to converge. So that means I'm now more and more relying on the group best search or the group best position. So that means this is now the process of the. Now my algorithm has moved toward the phenomena of the exploitation. So initially it was exploring when every individual was given freedom to find out the solution its own way. Then I will go on reducing it. Now we'll keep on that automatically after a few iteration, you know that the person who is going to find out the who is giving the best solution, accordingly the group move in that direction. So now that means the group is toward relying more on the collectively best carried out best find it solution. That is the moving from individual best to the global best location. That is how the exploration changes to exploitations. Then this is the P best position, particle individual best position. Ri is the random number which is generated. This random number, the role of this random number is to adjust the movement in the direction of the particle on best position, and in random, this is R2 is corresponding to the global best position. R1 and R2 are the random numbers between 0 to 1. This could be random vectors also. In case if you want to do, you can do it with the random vectors also. The dimension of this very random vector will be again the same dimension as that of this one. So this will be R1, R2 to RD. Okay, so this could be the random vector also, or it could be a random number also. And if it is a random number, every position will be multiplied in this way, scale down. Okay, and similarly, this is the random number. So this is Pi best is the particle individual best position. Xi is the particle current position at the ith particle current position. Ith Xi is also here the current particle on position. So two vectors will be there which will be contributing toward the velocity. I can represent this in vector form. That is the distance of the particle from its own best position, distance of the particle from the global best position, and C1 and C2 are the cognitive coefficient. Finally, this will be used to update the position of the particle in the search space. That is xt plus 1 at the t plus 1 iteration. This is the previous location, and this now A is your velocity scaling factor into V t plus 1. So different scaling factors are there. You can, if you don't want to just go with this, you can safely keep them 1 also. You can safely keep them 1 also. 1 here, and this random number will be, of course, decided to just this is equivalent to mutation operation in this way. So these are the steps: initialize the population, and initial velocity can be kept as 0. Then C1, C2 coefficients are to be defined. W inertia is to be defined. Fitness of each particle is calculated using this very position. Then based on this, step 2, G best and P best are selected for every particle in the group. Then velocity of the particle is updated as per that equation number 1. Update the particle position. Then iteration or stopping criteria, if your goal is achieved or not, then this one. Then finally the solution is lying in the G best solution. The main advantage, these are the main advantage of the PSO. Again, the same: global optimizer, derivative free, parallelizable, easily we can parallelize, need very less number of input parameters, only C1, C2 parameters are needed. Of course, weight and inertia you can add them. Okay. Then some of the limitations are there, and you can add some more method to prevent them from premature convergence. So every optimization algorithm is having problem of premature convergence. From this point of view, you will have to properly take care when the algorithm is systematically, or there should be systematical transition from the phenomena of exploration to exploitation. So this mainly premature convergence can be avoided if there is a smooth transition from exploration to exploitation. That is the main requirement. Sensitivity to the input parameters or the depend upon. So let us see how you can address this. You can use multi-swarm optimization. That means multiple swarms can be initialized in the search phase, which can communicate within themselves and the other groups also across the group. Attractive and repulsive particle swarm optimization. This technique is to inject diversity. So diversity is the main concept in all these algorithms into converging particle of the swarm so that they can be forced to do the task of exploration. In ARPSO technique, the diversity of swarm is measured, used further to switch the swarm into global attraction or repulsion. Okay. Then multi-start PSO, we can start and stop them multiple times. If there is no more improvement in the solution, then all the particles in the swarms are reinitialized randomly. Then adaptive PSO, it has been described by Shi and Abbott that selection of parameter PSO for a given problem is complex and difficult task. To overcome the complexity, parameter estimation researchers have tried to make the algorithm adaptive in nature. So this was this one. And we have also proposed one algorithm based on the adaptive jump strategy. You can find it out on the website. We have used the phenomenon of adaptive jump strategy. That means if the particle is getting slowed down, then randomly with the help of this very distance, we make it, as the distance comes down, we make it to forcibly jump out of this very well. And after the few generations, you can say that when we want to settle down, this adaptive jump, which we have interfaced with some values or made adaptive, will be, you can say that, forced to settle down. So depending upon this very magnitude, if this is coming down, it will be forced to take bigger jumps so that the diversity can be reclaimed. And this algorithm was performing well. You can find out, I will just give you the reference of this article. If you want to go through this is a very good article. You can search it. And then these are the standard test functions. You can see the multiple minimas locations. So this is the function corresponding to AICTE function. You can see that one global minima is occurring at this point, and this is gradually settling down with these very small minima. Then egg holder, you can see that in case of egg holder tray, this is then holder table function, this multiple minima at multiple location. Then Levy N1 function, ripple function in this way, ripple function, gradient type of this one such. Then test tube holder function. This you can see that you have seen that the test tube holder. Okay, and these are some of the mathematical formulas for this very functions. This is the function for restriction function. This is available in MATLAB directly. You can use it from MATLAB directly. You can decide its dimension and so on. Then this is AICTE function. This is the mathematical formula for this. You can write it down. Spherical test function. You can increase or decrease its dimension. The more the dimension, more will the complexity. Then this is Rosenblock function. Okay. And then these are the different, again in different dimensions shown in this way, different test functions for simulation. And you can also put the constraint. You can also put the constraint in which region or domain you are going to range you are going to find this out. Now let me quickly go through the applications. Application of optimizations in biomedical engineering. So in radiation therapy, this is the very one area where it has been continuously working for this very application. factor which affect the choice of the treatment. Radiation means high energy radiations are there to kill the cancerous cell. What is cancer? Cancer is the cells which are refusing to die. Cells which are refusing to die. So this is the problem with the cancer, that cells refuses to die and multiply at very fast rate. So this is the cancer actually. This may happen because of the n number of reasons. There could be n number of reasons. It could be like gene mutation or any other factors. So treatments include basically three factors: surgery, chemotherapy. After surgery, normally the radiation therapy is there, followed by the chemotherapy also, or the combination also. Okay, the size of the treatment will depend upon the size of the tumor and the position and location of the tumor and the type of the tumor also. You can also add this type of tumor also. That is, to which type of treatment it is going to well respond. If it will respond to chemotherapy only, if it respond to surgery and chemotherapy, or if it's respond to the combination of all the three: surgery, radiation therapy, and then followed by chemotherapy to kill the rest of the necrosis cells. The aim of radiation therapy, now these are the different objective of the radiation therapy, is to cause damage to the cancerous cell while minimizing the risk to the surrounding healthy cells. And sometimes, suppose if it is a brain tumor, you know that every cell of the brain is having some responsibility of the controlling any organ. It may be controlling the left side, left hand, right hand, or some internal operations or any other operation. So we try to do the minimum damage to the healthy tissue and maximum damage to the cancerous tissue. So the damage inflicted by radiation therapy cause the cancerous cell to stop reproducing, and thus the tumor shrinks. Okay, so this is the main thing which we are going to do. Just I have discussed to stop reproducing. So cancerous cells are needed to be killed and stop reproducing. Otherwise, it will regrow. Unfortunately, healthy cells can also be damaged by the radiations. So this is the one, but we can minimize it. We can minimize it, and this needs to be maximized. Damage to the cancer cells need to be maximized, and this needs to be minimized, but it cannot be eliminated. So the amount of radiation given to patient has to be accurately calculated so that the damage is limited to the cancerous cell only. This is the main our objective. Then role of optimization in radiotherapy treatment planning. Planning of radiation therapy treatment involves selection of several angle parameters. So radiation is to be given from the different angles. Angle parameters, this is one, as well as specification of structure and constraint employed in optimization process. That means which structures are to be avoided and which are to be maximum. So accordingly, we decide the angle and the intensity of the beam of the radiation. Including these parameter and the combinations are spaced vastly increases the computation burden, and therefore the parameter selection is normally performed manually as well as computer based. Manually by clinician based on the clinical experience, but nowadays the tools are there which are assisting this clinician in doing the computation in very quick way. Hence different optimization algorithms have been applied to this area, and this is still a very complex and challenging area. Steps in radiotherapy. First step is do the segmentation of the region of interest and mark the contour. Contouring is also contouring means laying down the boundary. Contouring or segmentation. So both you can either talk it as a segmentation. After doing the segmentation, its boundary or borders are marked. So segmentation will be based on the two steps. CT image you can use, or MR image, and PET image. PET image will give the functional area of the cells. In CT image, it is going to give the anatomical changes only, and they may not reflect where the active tumor volume is there. So the active tumor volume is decided by the PET image itself. Mainly it's the PET image we decided. Intensity modulated radiation therapy, IMRT, is a complex design technology to deliver precise modulated confocal radiation dose. Modulated means we can modulate it in this way, that where we are going to modulate and where we are going to keep it minimum. Okay. IMRT planning is further composed of the two steps: beam angle selection, from which angle we are going to deliver, and then dose optimization. What will be the dose which has to be given at a particular point? So these are the two main factors which are to be taken into consideration. And these are the steps: radiation therapy treatment planning. Of course, I have taken images from the websites to explain you. So the first step is the CT scanning, or coupled with the PET also. Nowadays CT PET goes side by side, so that's the functional size of the tumor and where is activated. That it may be happen that there may be a metastatic status, and it may be present at two locations, one at this location and because of metastasis at other location or at other organ also. Then tumor localization, you can mark the tumor localization. Then skin reference point marked on this very surface. Then treatment planning, that is from which angle and which beam we are going to do the radiation, or we are going to focus the radiation or bombard the radiation on the tumor. So this is this one. This is how this is decided. Then virtual stimulations are done. Then actual treatment with the help of, it may be linear accelerator, it may be cobalt-60 has become of course obsolete. Mainly nowadays the linear accelerators are used for this very applications. Then objectives involved: beam on time, aperture setup and X dimension, minimize total treatment time, acceptable dose in critical structure, that means minimum dose are to be given to this one. And these are some of the example. For example, in case of head and neck cancer, delivering too much dose across the spinal cord has the same effect as cutting it. And preserving salivary gland function is very important to the quality of life of the patient as well. So the dose volume histogram is an important tool that specifies for each dose value the fraction of the structure that receive at least that amount of the dose. So this is the dose volume histogram fraction. PTV, OAR. OAR stands for other organ at risk. Other organ at risk. Okay, if time is there for me to continue, or after this I can only. Okay, let me complete this first of all. Normal. This is the PTV, patient treatment volume. Then these are the dose distribution volume. Okay, patient treatment. So this is the 100% dose delivery, 95%, 90%, 70%. So in different, you can see that the gradient, the amount of dose is decreasing, 30% and so on. But our main target is to give the maximum dose to the cells where the tumor is located. This is this one. 100%, 98, 95, gradually go on decreasing. Excel plot of the dose distribution, maximum dose given, and where You can plot it where the maximum dose is given and where least dose or lesser dose is given. That means tumor cells are required to receive 100% dose for killing. Even if the dose amount is less, for example, if it is 0.8, it will not kill that cell. So that's why it is also saving the other organ at risk. Okay, and these are the mathematical functions or the equations which are involved in this. Okay, rate of cell kill per dose rate. This is an exponential formula. TCP stands for tumor control probability, and this way. Okay, optimization the model objectives. Okay. So now let me give you. Yes, if time is there, I can continue, or shall I stop?
Yes, sir, you can continue. 5 more minutes, sir.
5 more minutes. Okay, I will just quickly go through the application to this very
Okay, sir.
image segmentation area. So image segment enhancement is basically you can apply to the satellite images also. Understanding the satellite images also, they are denoising and deblurring. In medical field, we apply for this. The aim are to reduce the blur, at the same time to improve the contrast also. Mainly, most of the time, the filtering techniques also causes the information in filtering process. We also lose the information. Okay, in the process of filtering, some information is also lost, and sometimes it causes the blurring also. Okay, or the contrast is okay. Tissue contrast enhancement without noise amplification. So these are some of the applications. Artifact correction without loss of information, automatic segmentation, okay, and integrated diagnosis system for clinical use. So denoising and enhancement. So enhancement algorithm should improve interpretability and quality of image to make it better diagnosis. So these are the ground truth images. Okay, Ricin noise added, linear medium scale LMSE filter, then adaptive histogram filter. Now I'll just show you the application of PSO, genetic and simulated annealing. This could be applied. Then enhancement. So noise estimation, denoising, and this one. So this is the application of the optimization algorithm, which we have done through 2-3 methods we have implemented. We have implemented stochastic resonance also. We have implemented ant colony optimization also. Okay. So this is with least mean square algorithm. This is detection of microadenoma with enhancement as well as this one. So we have increased the confidence of the physician by this much level. Normally, this is the level of the confidence. By our technique, which we have applied for the optimization, that is multi-objective ant line optimization. This detection of the microadenoma, which is a very eyeball twisting exercise for a radiologist. This is very eyeball twisting exercise for radiologists to detect this. This has been improved and enhanced. Okay. Then these are the results of this one. So the greater difference in figure shows greater confidence in the level of diagnosis. That is the radiologist can clearly say that. Now this is with more confidence that this is the clear case of microadenoma of pituitary gland. Pituitary gland is very small, and its adenoma is microadenoma is very difficult. And you know that the pituitary gland plays a very vital and important role in controlling many of the functions. Okay, many of the functions. So detecting this and correcting accordingly doing the treatment plan is very important. So doing this is not an easy task. So for this, we have developed this one technique. Okay. Then intensity inhomogeneity artifact correction based on the dynamic stochastic resonance. So this is the original image and this is the corrected image. You can see that the information here is the intensity inhomogeneity, which is quite well corrected in this one image. Then these are some of the other application results. Intensity inhomogeneity. Here the inhomogeneity is there, here rectified. Okay, and so on. I can stop here right now. With this, I will like to just, of course, I included 2-3 more things, but because of the shortage, will not be able to complete. So thanks to all of you for your patience listening. Now, if in case if you want to ask anything, any queries there, you can definitely ask.
Participants, if you have any questions, you can ask.
Please, participants, if you like to ask anything. Any question or query?
If no question, shall I conclude it?
Yeah, definitely you can conclude.
Yes, sir. Sir, thank you so much for accepting our invitation.
Hello, sir. Hello, sir.
And this.
Hello. Hello.
Yes, Saima.
Yeah, Saima. Yeah, ma'am.
This can we use this algorithms for smart antenna, like optimization in smart antenna?
Definitely, you can use it for antenna applications also.
Okay, okay, sir. Okay, sir. Okay.
Ma'am, nowadays there are so many antenna minimization with the help of what is the microstrip antenna and all. So many these algorithms you can use to get a optimal antenna, ma'am. So there are some online lectures also available. You can go through and you can proceed with your research, ma'am.
Yes, ma'am. Yes. Thank you, ma'am. Thank you.
Thank you. Yeah, thank you all. Sir, thank you so much for accepting our invitation, sir. Sir, this is our second FDP. Thank you so much for immediate acceptance I got from you, sir. Thank you so much. And you explained well about the GA procedure, genetic algorithm procedure, and the various applications in the field of biomedical engineering, like in medicine and in how to do that particular particular algorithm in the various your realistic examples applications whatever you developed. Thank you so much for elaborated session, sir. Thank you so much, sir. Definitely we'll be in touch with you in our future events also, sir. Thank you.
No problem. So welcome.
Thank you.
Thank you, madam,
Yes,
and giving me an opportunity to discuss with you. Okay.
Sir, it's our pleasure to invite you, sir, as a part of our FDP. Thank you so much, sir.
Definitely. All the best.
Okay. Thank you, sir. Thank you, sir.
Shall I, if I can
yeah, sir. Yes, sir. Sir, 3 to 4 valedictory session is there, sir. If possible, can you please attend?
I will try to be there, but I cannot promise.
Okay. Okay.
Engagements at my end.
Okay, sir. Okay, sir. Thank you, sir. Thank you, sir.